Welcome to the DIY Honda Garage channel. The DTC P1157 indicates a malfunction in the air-fuel AF sensor circuit, specifically for sensor 1 in a Honda Civic from the years 2011 to 2015. This diagnostic trouble code signals that the AF sensor is not functioning as expected, which can affect the air-to-fuel mixture in the engine, leading to performance issues. The AF sensor, also known as the oxygen sensor, is responsible for measuring the oxygen content in the exhaust gases, allowing the engine control module, ECM, to adjust the fuel mixture accordingly. A miscalibrated fuel mixture can lead to poor performance, increased emissions, and potential engine damage. The sensor is located in the exhaust system, typically before the catalytic converter, and plays a crucial role in the vehicle's emissions control strategy. Addressing this error quickly is essential to maintain optimal engine performance and to prevent further damage to the exhaust system components. The primary component affected by DTC P1157 is the air-fuel sensor, also designated as Sensor 1. Located in the exhaust pipe before the catalytic converter, this sensor is crucial for measuring the oxygen levels in the exhaust gases. Its measurements allow the engine control unit, ECU, to adjust the air-fuel mixture, ensuring efficient combustion and minimizing emissions. The AF sensor plays a significant role in maintaining engine efficiency by optimizing fuel usage based on the engine's operating conditions. Additionally, it impacts the vehicle's overall performance, including acceleration and fuel economy. A failure of this sensor can lead to poor drivability and increased emissions, making timely diagnosis and repair essential. The potential causes of DTC P1157 include an open circuit in the air-fuel sensor's wiring, poor electrical connections, or a faulty AF sensor itself. An open circuit can occur if the wiring between the AF sensor and the powertrain control module, PCM, has been damaged or disconnected, interrupting the signal required for proper sensor operation. Poor connections, such as loose or corroded terminals, can create resistance in the circuit, leading to inaccurate sensor readings. Lastly, a malfunctioning AF sensor will fail to send the correct information to the PCM, resulting in erroneous adjustments to the fuel mixture. Each of these causes may result in the same DTC, which is why comprehensive testing is critical to pinpoint the exact issue. When DTC P1157 is present, drivers might experience several symptoms that indicate a malfunctioning AF sensor. Common symptoms include poor engine performance, where the vehicle may struggle to accelerate or maintain power under load. Owners may also notice a decrease in fuel efficiency, as an incorrect air-fuel mixture can lead to higher fuel consumption without the corresponding increase in power. Additionally, the check engine light will likely illuminate, serving as a warning that a problem exists within the vehicle's engine management system. These symptoms emphasize the need for timely diagnostics and repairs to ensure the vehicle operates correctly and efficiently. The first step in troubleshooting DTC P1157 involves verifying the problem. Begin by turning the ignition switch to the on position, or using the engine start-stop button to enter the on mode. Once this is done, the next step is to clear the DTC using the Honda Diagnostic System, HDS. This will remove any stored codes in the system. After clearing, start the engine and allow it to idle for 1 minute. During this time, monitor the system for any pending or confirmed DTCs. If DTC P1157 is indicated after this step, the issue may be replicable, leading you to proceed to the next troubleshooting steps. Conversely, if the code does not appear, it may indicate an intermittent failure, suggesting further investigation into connections and terminals at the AF sensor the PGM-FI subrelay, and the PCM. In this second step, an open wire check is necessary for the AFS Plus line. First, turn the ignition switch to the lock position, or off mode, to ensure the system is powered down. Use the HDS to jump the SCS line, effectively preparing the system for testing. Carefully disconnect the AFS sensor, Sensor 1, 4P connector, and the PCM connector B, which consists of 51 pins. Next, you will check for continuity between two test points under specific conditions. These conditions require the ignition to be off, ensuring no power flows while conducting tests. The test points consist of the AFS Plus wire, which runs between the PCM and the AFS sensor, critical for the sensor's operation. If continuity is confirmed, it indicates that the AFS Plus wire is functioning correctly, and you can proceed to the next step. If not, an open circuit needs to be addressed. Step 3 involves another open wire check, this time focusing on the AFS minus line. Similar to the previous step, ensure the ignition is still in the lock or off mode for safety. You'll again be checking for continuity, but this time between the AFS minus terminals. The specific test points are set between the corresponding pins on the PCM connector B and the AFS sensor 4P connector. Confirming continuity here is essential, as it indicates that the AFS minus wire is intact and capable of transmitting the necessary signals. Should there be no continuity detected during this check, it suggests a fault in the AFS minus wiring that needs to be repaired. Ensuring both AFS Plus and AFS minus connections are intact is crucial for the proper functionality of the AFS sensor. The final troubleshooting step involves testing the AF sensor directly. Begin by substituting a known good AF sensor, Sensor 1, to determine if the original sensor is causing the issue. This step helps in isolating the fault in case the diagnostics have not indicated a clear problem with the wiring or connectors. After substituting the sensor, ensure that all connectors are properly reconnected to avoid any new connections issues. Next, turn the ignition switch to the on position or press the start-stop button again. Utilize the HDS to reset the PCM, allowing it to recalibrate after the new sensor is installed. Finally, check for any pending or confirmed DTCs with the HDS yet again. If DTC P1157 appears, it may indicate issues with the new sensor. If the code is cleared, updating the PCM software may be necessary. Or if the original PCM is faulty, substitute it with a functioning unit. After completing the necessary repairs for DTC P1157, it is imperative to conduct a final verification of the work done. Start by checking that the DTC has been cleared from the system. This indicates that the repairs have successfully resolved the issue. Following this, it's advisable to perform a test drive under various operating conditions to ensure the engine runs smoothly and does not exhibit any symptoms previously associated with the DTC. Pay particular attention to acceleration, power delivery, and fuel consumption during this process. Finally, recheck the engine performance through the diagnostic system to ensure that there are no pending or confirmed DTCs, confirming that the actions taken have rectified the circuit malfunction and that the A-factor sensor is effectively managing air-fuel mixture ratios within normal operating parameters. Preventive maintenance plays a critical role in avoiding repeat incidents of DTC P1157 and ensuring optimal vehicle performance. First and foremost, regularly inspecting electrical connections associated with the AF sensor can help identify potential issues before they escalate to full failures. Keeping connections clean and secure also prevents oxidation and corrosion. which can lead to poor performance and signal integrity. Additionally, using high-quality replacement parts when servicing or replacing the AF sensor is essential. Quality components often have better tolerance, longevity, and reliability, which aids in maintaining proper engine operation. Lastly, ensure that the exhaust system is kept clean and free of obstructions, as blockages can negatively impact sensor performance and lead to erroneous data being sent to the PCM. Implementing these maintenance practices can significantly increase the longevity of the AF sensor and the components associated with it. In conclusion, understanding DTC P1157 is essential for effective vehicle diagnostics and repair. This trouble code indicates a malfunction in the AF sensor circuit, which is crucial for maintaining optimal engine function and emissions control. By following the outlined troubleshooting steps, technicians can systematically identify and rectify the issue, whether it be a faulty sensor, wiring issues, or poor connections. Furthermore, engaging in regular maintenance can prevent future occurrences of this DTC, ensuring the sensor and its components are functioning reliably over time. The combination of thorough diagnostics, proper repairs, and proactive maintenance provides an effective strategy to keep your Honda Civic performing to its best capability and efficiency. Please like and subscribe to the channel. See you next time.